morning, people. Good morning, Purnima. Good morning, Prajwali. Ganesh, good morning. Good morning, Manasi. Good morning, Tejas. Achal, good morning. Mitali, good morning. Yuga, good morning. Kriti Patil, good morning. Bini, good morning. Pooja, good morning. Durvesh, good morning. Ashutosh, good morning. Achal, good morning. Nikita, good morning. Swarada, good morning. Anjali Kumari, good morning. Rutuja, good morning. Rasika, good morning. And Prachi, good morning to you all. Since the number that has joined in is less, Anuja, Kalyani, good morning. A few instructions that I wanted to give would come towards the latter part of the lecture. Let us immediately shift to what we are supposed to be doing today. And I'm going to share the screen with you all. And yeah, we were doing the basic principles as far as geomorphology is concerned. And we went through these aspects yesterday, the first slide, and then we said geomorphology is the study of earth landforms. Okay, basically something that is happening very recently from the quaternary period onwards. It's these landforms that reflect a local and regional balance between the hydrologic, tectonic, aeolian, glacier or glacial, atmospheric and marine processes. Why is it important? I'm going fast basically because we have done this yesterday and we have a lot more slides to be done today. We need to understand the geomorphic processes. Why do we need to understand these geomorphic processes? Is basically to detect natural hazards and, of course, to know about the vulnerability with regards those as such. Okay, an important aspect of this is the geological time scale, which we need to know broadly, at least, if not minutely. Then it's basically geomorphologists look at the processes, trying to understand what created the relic landscape, what are the present landforms or present processes affecting them, whether they are destructional or whether they are constructional. We spoke about what destructional means and what constructional means in the natural sense and the human sense as well. We skipped this slide, and then an important slide we spoke about was the order that we come up as far as the scale of geomorphological features, both the spatial scale, that's how much space that particular landform occupies, and the temporal scale as to what is the frequency of that particular landscape being changed, altered as such. So on the largest scale, we have the basics, that is continents and ocean basins, and then we go down and down, and you'll see that the larger larger spatial scales require larger temporal scales to be altered. On the other hand, smaller temporal scales or smaller spatial scales require lesser amount of temporal or time as such. Okay, this was the scale of the landforms. Age of the landforms, larger landforms are more durable. We just said that. And then we spoke about the rise of the geomorphic thought, not called as geomorphology then, but you have Herodotus initially, and then we are going to look into further till after 1700s. You have Hutton and you have Agassiz, Powell, Gilbert, Davis, and others. Herodotus speaks about marine fossils in the Nile Delta, followed by Aristotle, something on similar lines. Okay, then you have Senna, and you have the Ibn Sina, and that's the say ancient period includes up till erosion of valleys of running water. Then you have the medieval period, Ibn Sina, wherein the Arab geography was very prominent, and he is seen to conclude that mountains could be uplifted and later eroded. Then you have Leonardo da Vinci, 14th century or rather 15th century, found marine fossils on land, and followed by him you had Bauer, who hypothesized that mountains were sculpted by weathering, very similar to what Ibn Sina had said earlier. Steno contributes in the 17th century that mountains were sculpted by weathering, and sorry, we missed out on a few things. Yeah, we spoke about evolutionary geomorphology, wherein, just give me some time. Yeah, sorry about that. Um, Break, I would rather say. And yeah, we have W.M. Davis, who is immensely impacted by Darwin, and he says that everything on in geomorphology works in what Darwin says is the cycle of life, and accordingly, he says that the stage of evolution is determined by examining the characteristics of life cycle of the landscape, and he implies that time has a critical factor. So structure, process, and time are the three constituents, he says, are important. And having said that, he says that he gives this famous phrase saying that A landscape is a function of structure and process over a period of time. Okay, and a confluence of all of this is a resulting landform. Whether the landform is, so to say, um, young or adult or old, all will be decided on the amount of time that processes have spent on that particular structure. Okay, so structure is basically what makes up that landform. Process is the constructive or destructive process on that. It could be modern or it could be relict, and time stage is landforms evolve through stages from continued action. Okay, so these are a few photographs here. Okay, this is how we had an idea about this yesterday also. The young landscape, the mature landscape, and of course the old landscape, which Davis identifies as a penny plane. And then we went ahead and we spoke about a dynamic equilibrium. Now, what exactly does dynamic equilibrium mean? Of course, after that, you had this quantitative approaches where we use mathematics, a lot of mathematical equations and statistical theories in establishing a few rules, establishing or confirming a few rules and laws. And nowadays, computers, satellites, Landsat imageries are being used, aerial photographs are being used. All these are improved data techniques. Equilibrium is that the whole thing trying to establish a so-called balance, but balance is always not good to be in favor of, something not to be good in favor of. I did explain how imbalance is critical as far as human life, a basic process in life, that's respiration, is concerned. The same things were applied to the concepts of equilibrium, wherein from erosion to deposition, okay, the medial stage is transportation, and this is the fluvial equilibrium, that this block of erosion will eventually, sorry, fill up the block of deposition, and there would tend to be a balancing out in the whole scenario as such. Okay, this balance or equilibrium is related to something called as base level of erosion. Okay, and as far as these base levels are concerned, sea level is the ultimate base level, basically because I said yesterday that the source of major agents of erosion is water. The source of this water is ocean. So once this water from land travels back to the oceans, the cycle is complete. And because the cycle is complete, once the water meets the ocean, it does not carry out any further erosion as. Okay. Lakes and reservoirs, by the way, these are stagnant water bodies. These are temporary base levels as such. Change in sea level will cause change in base levels. Let me tell you, will take fall in sea level will of course recede the mean sea level, and thus it will aggravate the erosional processes further. On the other side, if there is going to be a rise in the sea level, then many processes could be cut short, particularly towards the delta as such. Changes in base level create and destroy accommodation spaces. Okay, this is a longitudinal profile. Okay, while you see this in block here, this line here, this is the longitudinal profile from the height of that particular stream to the mouth of that particular stream. In other words, as you can see here, if you're looking at a river sideways from its origin to its mouth, you are actually looking at its longitudinal profile. But if you're looking at the river from the front, then of course you are looking at a cross section. These cross sections vary with the stage of that particular river. In the upper stage, it's V-shaped. In the middle stage, it is U-shaped, and in the lower stage, it further opens and it is called as it happens to go trough-shaped as such. Okay, this is how the longitudinal stream profile looks like. The attempt of the stream is to bring all this to the base level. Okay, it will always try to do that. And you'll see that if this is a graded profile, yesterday we said it's in balance of transportation, erosion, transportation, and deposition. Anything above the this longitudinal stream profile would be an attempt to cut that and to fill up what is below this. Okay, so this is a very interesting concept, important concept, that something above the graded profile will be eroded and will be deposited in locations where it's below that. Okay, so you'll see that first stage, second stage, third stage, 1, 2, and 3 will fill up 1, 2, and 3. Okay, so this is the new longitudinal profile of equilibrium, which is eventually, but um, in invariably, you'll see that you hardly would have rivers who would be in a perfect equilibrium, because that is not what the forces will intend at. Now, what are these forces? The internal forces and external forces. We are going to go to these forces in just a moment of time. Coastal equilibrium is something that we don't need to do today, and is not a part of your syllabus immediately. Geographic processes. Geomorphic processes include uh, formation and alteration of the Earth's surface. Formation is the structure, alteration is the process, if we need to compare this statement to what Davis had to say about the physical and chemical interactions between the Earth's surface and natural forces acting upon to produce landscape or landforms. The processes are determined by such natural environmental variables such as the geology, climate, vegetation, and of course, most importantly, base level. And normally in a natural environment, none of the human interference, but nowadays we will see that there is a significant amount of human interference in the whole process. Further continuing geomorphic processes, there are different definitions. Okay, Thornby says that processes are all those physical chemical changes which affect modification of the Earth's surgical form, landform, is what he means to say. Then Gardner says that a process by which the Earth's landforms are changed or maintained. Okay, changed or maintained is a difference that he brings in here. Then agents, processes of these products. You'll see that rivers will be dominant in humid geomorphic environment. Wind would be dominant in arid environment. Glaciers would be dominant in polar environment, and waves would be dominant in coastal environment. Agent, processes, and products. Processes include erosion, transportation, and deposition, the most important activities. Now, who does this is something of say further study. Okay, but let me tell you that since your syllabus restricts ourselves to river geomorphology only, we know that the river erodes, we know that the river transports, and we know that the river deposits as well. But let me tell you that similar thing happens with wind, similar things happen with groundwater, karst topography, similar things happen with glaciers, similar things happen with waves. Okay, the only thing is, given the condition of that particular agent, these are called as agents of erosion, 5 major agents of erosion. Normally, we study river at the primary level, then we go into further depths as such. But remember that the processes remain the same in all the three. There will be erosion in all the five, sorry. There will be transportation in all the five, and there will be deposition in all the five. Given this, you will have erosional landforms in all the five. You will have depositional landforms in all the five. That is what I meant to say when I said that once you know the basic processes of geomorphology, handling agents of erosion and other things is going to be easier. So keep these things in mind. Erosion, there are basic processes will lead to that, okay, irrespective of the agents. Deposition, again, there are basic processes irrespective of the agents, is something that you have to keep in mind very, very seriously as such. What are the products of geomorphic processes? Okay, the processes, as I said, include erosion, transportation, and deposition. And I've just said that the products include erosional landforms. Transportation is something that happens in the process. It's a scientific process. Thus, you don't have transportational features, landform features. You may have them, but on the scale of time, they are going to be very, very small, and that is why they are not studied intensively. Okay, because transportation is a dynamic process. Okay, for geomorphology, you have to have a stable process. So you'll either have them as erosional landform features, or you will have them as depositional landform features as such. Okay, so this is something that we have to keep in mind. What are these agents of change? Here you will see here the river activities. This is a meandering river, extensively meandering river. Here you can see how this is. This river is has left back oxbow lakes here and there, all the way here. Then you have the wind activities. You have these dunes, okay, which are barkhan shaped. These are called as barkhans. You'll see that one side is much steeper than the other side. Normally, the steeper side is where from where the wind is blowing, and the gentle slide is the leeward side of the winds as such. Then you have glaciers. This is a glacier. This white thing is a glacier here, and of course, then you have snow in the backdrop. Okay, you'll see water could be oozing out of that, and then here you have the wave activities also. Now, given all these things, okay, understood all these basic things, what should I be understanding about geomorphic processes? I'm purposely trying to put the whole thing in one scenario. I'll just hide this. Yeah. Now, geomorphic processes, or we could have written there the subject of geomorphology. There are two basic processes: terrestrial processes and extraterrestrial processes. We are not much interested in extraterrestrial processes because the rate at which they tend to happen, extraterrestrial processes, particularly when you are referring them to terrestrial processes, they are not comparable. Terrestrial processes happen so very regularly. Extraterrestrial processes happen only occasionally. Let me see. Yeah, so this is something which is extraterrestrial: shooting stars and meteors and so on and so forth. Going back to this thing here. Terrestrial processes are further divided into two: exogenetic processes and endogenetic processes. Endo comes from inner part, exo comes from outer part. Is something very simple to remember. Endo is something from the interior of the earth. Exo is something from the exteriors of the earth as such. I could say that what Davis referred to as structure and process, okay, is structure comes from endogenetic processes, and exogenetic processes is what did he say? Just to go back very fast and come back here. Let us see what he had to say about it. Yeah, you will see structure, process, and time is what he says. Let's go back to where we were here. So, because endogenetic processes are the first to happen, because had we not had endogenetic processes, exogenic processes would not have been in action. So endogenetic processes. There are two types of endogenetic processes. On a broad scale, they are fast happening and they are happening very slowly. Now, fast happening processes is number 2 and number 3 here. To some extent, I would say number 4 also. Volcanism, earthquakes, and landslides happen very, very fast. On the other hand, you will see that faulting and folding happens very, very slowly. Diastrophism are slow movements, and metamorphism is also very slow. So, on a broader scale, but these are the major types of endogenic or endogenetic processes. And these, once when they form, the volcanoes when they erupt, earthquakes when they occur, landslides when they happen, folding and faulting when they are observable, then you will see that on these start happening what are called as exogenetic processes. Now, what are exogenetic processes? There are 3 basic types of exogenetic processes: weathering, mass movement, and erosion. However, some scientists do not agree with erosion as a separate process. They say that it's one of that process, and thus some of them say that erosion, transportation, and deposition need to be included in that. But then there is an interesting term, denudation. If you look for this word in dictionary, it basically means scraping off, removing. Okay, so how do rather the exogenic processes denude the surfaces, the structure which is formed out of endogenetic processes is through weathering, erosion, and transportation. I would rather say weathering, mass movement, erosion, and transportation all together are called as denudation. Of this, weathering is physical, chemical, biological. So you'll see that the whole thing in geomorphology, I can see the whole geomorphology in front of me in one slide itself. It's gradually that I go into the details of each of these topics and subtopics that I can see in front of me. But basically, geomorphology to me is nothing outside this. Okay, if I want to take in all of it, I would further shrink it a bit, and yeah, further. This is the whole thing that I am actually studying in geomorphology. Nothing beyond this is the scope of your first semester paper 1. Everything in first semester paper 1 is going to be limited to this particular slide. You show me a point outside this, okay, and we'll exclude it from your syllabus. Okay, you'll see that everything associated to your syllabus is involved in this particular thing here, that slide that you can see in front of you. Okay, let us go to for a bit of detailed explanation of what we did as one slide here. Types of geomorphic processes: terrestrial, extraterrestrial. We've just said that falling of a meteorite or a comet, etc. All these are extraterrestrial processes. They will cause deformation, construction, destruction of the landform. Terrestrial processes include exogenetic or exogenous processes, endogenetic or endogenous processes. What do these include further? Extraterrestrial processes, you can see comets, meteorites, and you can see how red they have gone. Okay, now let us come to the types of geomorphic processes. Exogenic or exogenous processes. Now, because this presentation is that way, they have started with exogenic first. If I would be doing this presentation, I would have started with endogenetic first. Anyway, eventually we need to come back to the same point, and that is geomorphology. Outer geomorphological processes, exogenetic processes, will include solar radiation, wind, temperature changes, water, creation of relief sculpture. Now, of all these things, if you ask me what is the most important of those, I would say this is the most important. The solar thing is very important as such. Okay, because all that is going to happen is with regards solar radiation. Okay, solar radiation. What does solar radiation? Now, actually, that's a part of your second semester paper 1, but you'll see that it is because of the solar radiation that the surface is heat. Because of that, you're going to have what you can call as uh, temperature changes. It is these temperature changes which will cause uh, what? This is going to cause water to evaporate, isn't it? And this will and where you don't have water, or rather where you don't have any form of water, you'll see that wind is going to take up the whole challenge of processes. So this is how the connection is. The most important of them is solar radiation. If we had not had the solar radiation, we would not have had temperature changes, which would not lead to the water cycle, and lack of water cycle either would not have led to wind and wind activities as such. So this is the most important thing that you have to remember when we speak about exogenetic forces as such. Now let me tell you and remind you one thing, that solar radiation in itself cannot make these things happen. Then your obvious question would have been, sir, how is it that you say it that way then? Okay, you'll see that why they have put solar radiation here along with others is solar radiation. If you have solar radiation on any other planet, it will not lead to effects like temperature changes, water, etc. As such. It is solar radiation in combination with the atmosphere that is around us, which is important. So solar radiation hits the atmosphere, and it is the atmosphere which leads to temperature changes, water cycle, and wind activities as such. So that's an important aspect that you have to remember, that it's solar radiation in combination with the atmosphere, and that is why you always find those Venn diagrams, okay, wherein you have the hydrosphere, you have the lithosphere, you have the atmosphere fixed into each other. We saw that diagram much way back into time when we were doing the thing out of Strahler's book as such. Okay, let us go back to what are the types of geomorphic other geomorphic processes. Then you come to endogenic processes or endogenetic processes. Inner geomorphological processes or endogenetic processes lead to earthquakes, volcanoes, folding, and faulting. They roughen up the Earth's relief, I would say. And exogenic, basically, they smoothen up. Now, how do we say that the Earth is an active planet? If any of these one only exclusively would have been in operation, say for example, only exogenetic would have been in operation, the Earth would have been smooth as a marble, let me tell you. Literally as smooth as a marble. And had it been only the endogenetic, the Earth would have been very rough like a porcupine. You would have features here and there. That the Earth is not completely smooth, neither is it completely roughed up, means that there is a continuous process of friction going on between endogenic and exogenic processes. That's another takeaway point that you have to keep in mind. As what is the difference between these two processes? Processes that are caused by the forces from the inner part of the Earth is endogenous. Processes that come from outside is exogenous. Uh, the table here reads that they originate from the interior of the Earth, originate from the surface of the Earth. They cause sudden or rapid movements. I would not agree with all of this, basically because folding and faulting are not sudden, by the way. Okay, cause slow movements. Again, here I would not completely agree, basically because some activities, say for example, a dust storm or a wind storm is not very slow as such. So with some restrictions, we could agree that on a very broad scale that endogenetic is from the interior, exogenic is from the exterior. Exterior processes are slow, but not absolutely. Endogenic also are sudden, but not absolutely as such. So this is how we can understand this particular slide for our purposes. Uh, Types of exogenic processes include weathering. I would say I would take this aspect, mass movement, up to number 2, and then I would speak about erosion, degradation, transportation, and deposition. All of this put together is called as denudational process. Okay, here is what denudation means. It means to make things exposed, to scrape things, the process by which rocks on the earth of the earth's surface are broken into pieces through application of external or physical forces, and a debris is transported elsewhere is known as denudation. Denudation work is performed through 3 processes such as weathering, erosion, and transportation. I would partially include mass wasting here as such. Okay. Now, what is weathering out of this? We're going to do this as a chapter, remember. But the most important characteristic of weathering is disintegration or decomposition in situ. Okay, in situ. What would in situ mean? In, I try to write it in S I T U. In situ means there and there itself. I will just try. I don't have my pen. Tomorrow I'll use my pen. So this is what we mean by weathering, when disintegration and decomposition takes place there and there itself. There is no transport. There is no transport. And this happens due to various processes. Let's rub this off. Okay, and yeah, fine. So this is NC2, disintegration and decomposition. Okay, we'll go into the details next in later. Okay, here material is not transported elsewhere is the important takeaway from the slide on weathering. What is erosion? Okay, you'll see that erosion and transportation are accomplished together. Okay, and that's why it is separated from weathering. Okay, the process by which rocks on the Earth's crust are eroded. You'll see how they are moving down here. Okay, so this is erosion. Degradation. Now, this is another term that we need to understand with regards geomorphology. You know this as a dictionary term, but let us understand with the sense of geography. Degradation, degrade, bringing it down. So you'll see here you have 4 layers. It has been degraded to 2 layers further degraded to 1 layer. Okay, so conceptually it is the opposite of vertical component of aggradation. We're going to come to the second term, which is opposite of degradation, aggradation. Okay, so in a river, for example, you'll see that it scrapes away the surface and it degrades the channel. Okay, and that is how the channel goes deeper. Okay, deposition is something like this, very similar to a truck dumping material. It deposits material. Okay, so that's the same thing as accumulation, how materials accumulate in a particular area as such. And then you have aggradation, which is an opposite of degradation. Okay, from a single layer you have the deposited material and it dumps into a particular area, and then you have further dumping on that. All of this will cause a vertical accretion. Okay, aggradation as such, elevation of the surface as such. Aggradation and degradation are processes opposite to each other. Sedimentation is another term that we need to understand. Sedimentation is the process by which sediment is mechanically deposited from suspension there are various processes how sedimentation occurs. I would like you all to, I think we spoke about competency and what was it? Capacity and competence. I don't know if I've discussed it with you all. Please let me know if we have discussed about competence and capacity. Okay, because many a times normally in English we consider them to be synonymous terms, but scientifically they are different. Okay, if I have not spoken about it, we will speak about it later. Let us move ahead. Mass movement. Okay, you'll see that this is where there is no disintegration, there is no decomposition as such, like in erosion and weathering. But here you'll see that it's only movement. No one is involved, but only movement. And how does this movement occur? This movement occurs because of the gravitational force. Gravity is the most important component as far as mass movement or mass wasting is concerned as such. Okay, and the speed at which this happens, I have very interesting PPTs on that, and when we come to these topics I'll go into absolute details of this and you will know it then. But rates of mass movement range from very slow, that's called as creep, to very fast. It's going to be a rock fall or a landslide and so on and so forth. So that's mass wasting. Okay, so once again coming back to those very geomorphic processes, once we have gone through what each of them were, okay, here now we move to endogenic processes as such. What is faulting? Okay, this is basically due to tension. Okay, due to tension you're pulling it away from each other. You'll see that if I'm going to pull this away from each other, I take something I have to destroy. So if I'm going to pull this away from each other, what is going to happen? Okay, you'll see that it may this, and this is the very thing that happens as far as faulting also is concerned. Now because this is something, this is a postage, this went again. Now this, along the crease with which it has torn apart, this is very similar to a fracture or a fault. Okay, you'll see that. Now because it had a lot of space, my hands could go otherwise. It tore in this particular way. Now, if this is going to be a globe like this and it's compacted as such, when there is a tension, okay, you will see that it will either move up or it will move down. Okay, this movement up and down is basically a normal fault and reverse fault. We'll be going into the details of this once again, but I think you have done this. The only thing that you have to uh, remember out of this probably is the tension that happens in the globe. That's the surface of the earth as such. And while this happens, you'll see that the movement happens upwards or downwards as such. Okay, there are various types of faults. We're going to come to that. Then you have folding. Okay, you'll see that the same thing, if I'm going to push it into each other, you'll see that this um, paper starts folding, and you'll see that if I'm pushing this only and this is stable, the output is different. If both of them are moving, the output is different. Sometimes one is very stable and the other one keeps on riding. Okay, this is going to be an overturned fold. So you'll see that folding is again a very interesting process that happens, endogenic process which happens, okay, around us. Okay, the elements anticline, syncline. Okay, we're going to go into those details later. Then this is the most how I would say threatening of endogenic activity is volcanism, because it erupts molten magma, which when it comes out is called as lava. Okay, and there are various types of volcanoes. Okay, active, dormant, and extinct, and of course features related to that. And then you have something which is called as an earthquake, which again is if this is the surface, the shaking of the ground is basically it, and with it shakes everything on the crust, and this could lead to a lot of destruction. Okay, this is landslides. Okay, how they occur. And another term that we need to understand in geomorphology is diastrophism. Okay, it's called as tectonism. Also, large-scale deformation of the Earth's surface by natural processes. And natural processes basically mean from the interior. Okay, it's the release of heat or magma or whatever from the interiors. That's called as diastrophism. It leads to formation of continents, ocean basins on a very large scale, mountain systems, plateaus, and rift valleys on a smaller scale as such. Okay, internal forces, as I've said, internal forces are active here. Metamorphism is something related to pressure and temperature. We use more of this with reference to rocks, metamorphic rocks as such. It is a process which can change rocks physically, long-term heat, pressure, and introduction of chemically active fluid. Okay. And once again, we come at a general glance at geomorphic processes as such. Land forming processes, slow changes, sudden changes of two types. Slow changes, denudation, deposition, weathering, erosion, transportation. Slow and sudden changes, diastrophism. Sudden changes, earthquakes and volcanoes on a very broad scale. Okay, so this is the last of the slides we were supposed to be doing. Okay, I'll stop sharing here, and okay, let me take the questions here. Gautam says, okay, yeah, we had that problem initially. Yes. Yuga says the video has stopped, right? And yes, and then of course it started a bit later, and we went back on live. Okay, now somebody says lecture chal raha hai kya? Yes, chal raha hai. I don't know, Mayuresh had to say what Mayuresh had to say when he wrote all geomorphic agents. Akshata asks us, why don't we say water as an agent of geomorphological process instead of water and instead of waves and river? Yeah, a very interesting and important question, I would say, Akshata. Thank you for the question. You'll see that if we look at the agents of erosion, except for wind, in fact, I could relate wind also to that. Water is a natural substance. The environment in which water moves is going to give you a different context of calling it in the different ways. In the sense where you don't have water at all, you're going to call it an arid environment, and this arid environment will lead to a different set of landforms. Okay. Now, when the water starts flowing, okay, the flowing of water is going to be called as a river, and that river is going to give you erosional and depositional features. This river is made up of fresh water. On the other hand, waves are made up of saline water. Okay, and the process with which that happens, okay, the basic characteristics of water remain the same. However, the behavior of water in the clouds, behavior of water in the rain, behavior of water in the river, behavior of water underground, behavior of water when it goes solid, behavior of water when it is in marine environment is all different. And this will yield you different types of landforms. And that is why we don't call all of them as water as an agent. We call rivers separately, we call glaciers separately, we call karst erosion, and we call wave erosion separately. I hope that answers your question, Akshata. Okay, let us move ahead. What is faulting and folding is another question Akshata comes up with. As far as the crust is concerned, as I said, that if this is the part of the crust, yes, Mayuresh, I'm coming to your question as well. What is folding and faulting? So if this is the crust, and if I'm going to pull this away, this is going to be tension, is what science students would understand in physics, tension, and this is going to be compression. Okay, so I showed you all that when there is going to be tension, okay, this is going to split away from each other. Okay, on the other hand, when I'm going to have compression, I could have folds. And you'll see that the folds would look differently. I'll take a fresh sheet so that it. Yeah, this we spoke about this. This is a fold, and as far as this fold is concerned, as I said, how the two compressing factors are. Okay, that will decide what type of fold. Is it going to be asymmetric, asymmetric? Is it going to be isoclinal? It is going to be recumbent, overturned. All these different types of folds. It's basically a diastrophic phenomena, which leads, which is a signature, I would say, of compression and tension. The signature of tension is faulting, and the signature of compression is folding. Is the best I can put it here, because we don't have to go into the details right now. You'll have to wait for before we go into the details. Akshata says understood. Now, whether she understood the aspect of water or folding, I don't know. Then Mayuri says that denudation. You'll see that denudation is a common term used for exogenetic processes, I would rather say. It's a common term of scraping everything that is on the surface. So instead of saying that yes, erosion is doing something, instead of saying weathering is doing something, instead of saying mass wasting is doing something as such, all of it put together, I would say denudation. So when I say denudation, I would mean that weathering is happening. I would mean that mass wasting or mass movement is also happening. And I would say that the agents of erosion also are in action. Now, which agent of erosion? That depends on the local environment. If there is a lot of rain, obviously you'll have a river. If the temperatures are low, the same river will be a glacier. If the surface is made up of sedimentary rocks which are porous, the water will seep down, and then you'll have groundwater, and so on and so forth. So this is going to be the difference. So you mentioned about meteor. Are we able to see coming meteor shower on 13 December with our naked eyes? I am not very sure. This is news to me. I'll check and let you know as to what is to happen with regards the 13th of December. I think we should be able to see it. It all depends. You see, every meteor is going to be visible to the naked eye. The only thing is that how frequent is this shower going to be? If there is going to be a lot of meteors falling, then of course the possibility that you trace any one of them is going to be easy and you could see. But you have an occasional one falling here and there, then of course it tries your patience. and unless and until you know whether it is going to be occasional or whether it is regular, locating meteorite falling is going to be a difficult task, I would rather say. So if yeah, once we have finished with that, a few things that I wanted to share with you all when I started the lecture, because a lesser number of students were there, I kept it for the latter part. A number of students are posting messages on the group, as well as some of them have trying. Uh, Akshata says, means, is it going to be visible from Pune? Let me confirm, I'll let you know. Yeah, coming back to the fact that students are asking me on personal chat also as to what is the syllabus. Everything that we are doing presently is a part of your syllabus. Okay, what are the books? Okay, as I said, I don't follow one particular textbook, so using a particular textbook could be a bit risky for you all, but I would say that reading topics from the syllabus, I think I did speak about this earlier also, that you have to keep your syllabus ready, and that's true for every subject, not necessarily only geography. Keep your syllabus ready, read the terms from your syllabus, find those terms in all those reference books that I have stated, in the sense the Strahler book will have some part of it. The NCRT books, 11th and 12th standard, will have them in it. Then the Go Cheng Leong Certificate of Physical Geography book is also being posted. So in one of these books, you'll surely find that particular topic. You need to go into the details of that. You need to make your own notes, because visiting each of these books every time is going to be difficult. So you read from one book. If you find it's very interesting, you can of course go into the you can make down points out of that, and you can keep them as your notes as such. So that is about syllabus, that is about reference books. One more thing that I wanted to share with you all is particularly those who have joined the class late, that parallel to the to the FYBSc regular lectures, I have a group which is made up for those students who have done their schooling, because geography is a subject which normally students take up till 10th. It's compulsory subject till 10th only, then it becomes optional. So not many students have geography. And students had a bit of confusion about this, as to how do they look at geography if they have done their geography in Marathi. So for such students, I have formulated another group as such, and we meet. Of course, we have not met for 4 or 5 weeks, last 4 or 5 weeks, but then uh, as far as that aspect is concerned, those who wish to attend, now this is going to be beyond your lecture schedules as such. Normally we do it on Saturday, because till Friday I see you all are busy. Having said this, Vaishnavi, I'll let you know when the exams are going to be conducted. There will be an official notice about it, and the vice principal will share about it. As of today, what I think it's your internals are going to be separate and your finals are going to be separate. There is a certain number of days that needs to be, the teaching needs to be conducted. It's only after that that we can conduct your final exams as such. And again, whether if it is going to be MCQ based or whether it is going to be subjective is still to be decided. You have to be prepared for both of them, MCQ or subjective, both ways. And of course, you are going to have some internal evaluation activity also. We are going to do, yesterday you sent PDF on the group, so we can refer those notes. PDF, I don't know which PDF Saket Shinde is speaking about. The PDF I sent about is this very PPT. I don't remember any other PPT PDF that I've shared with you all. But yeah, coming back to the fact that Marathi medium students who would be interested can join that particular group in some time from now. I'll once again share the link, and let me know. It's high time we have not met in the Marathi channel, I would rather call it. So the earlier we meet, the better, because I think a lot of lectures have happened since then, and we have not spoken about those lectures in Marathi as such. Uh, that is all I had to share with you all as far as the day is concerned. Um, Next time we meet, that's Monday, we'll go into some other topic. Till then, If you don't have any further questions, I would like to stop here for the day. Thank you for being there. Have a good week and weekend as well. I'll end my broadcast here.